Okay, so let me show you what we're going to do today. So on Thursday last week, I gave folks an exit ticket, and this is like a short quiz, but it's not for a grade. So zero pressure, zero stress. It's just do the best you can. Let me see where you're at. Let me see if people are making common mistakes that I can fix. And everybody did an awesome job. There were a couple small mistakes. I was able to address them and talk to some individual people. So this is what your quiz is going to look like today. We're going to be expanding our understanding of exponential functions. I don't want you writing this down right now. Just look up here for a second. We're going to expand our understanding of exponential functions. We're going to be using a little bit of what we learned on Thursday. But now instead of just having an equation with one number in it, our equations are going to have two numbers in it. Okay, if you look at your notes from last Thursday, we just had B. We were just dealing with B, correct? And if B was bigger than 1, it was growing. If B was between 0 and 1, it was going down. Do you remember all this? All right. Well, now we're going to have A and B. So this is what we're going to look at. I'm going to give you an equation and ask you to find A and B. I'm going to give you a table and ask you to find A and B. I'm going to give you a graph and ask you to find A and B. We'll be doing an example of each of these in our notes today, and then transferring some examples into our packet as well. So you're going to want to have your notebook out, whatever you do your examples in. And then we'll also transfer some information into our packet. So that's where we're headed for today. Okay. So make sure as we're going through here today, you're paying close attention to how do I find A and how do I find B? So to start off, I'm going to put this first thing right in our packets. And this is going to be the general form of an exponential function. General form of an exponential function. We did the basic exponential function on Thursday. We're going to expand that today and do the general form. I'll be honest with you. If you missed Thursday last week, but you understand what I'm showing you today, then you don't need to worry about going back and getting Thursday's notes into your packet. Okay. If you can understand this, this includes everything that we did on Thursday. So our exponential function equations are going to expand a little bit. Now they're going to look like this. Y equals A parentheses B and parentheses to the X power. And our goal for today is to see if we can figure out what is the meaning of this A and what is this meaning of this B? And then how do we find those values when we're looking at equations and tables and graphs? That's where we're going with this. All right, so I'm switching over to my notes here. And I'll give you a page number so you can get to the correct page. We're going to be on page 317, 317. We're in section 7.1.2, and we're going to start off with number 20. We'll be doing most of problem 20 and 21 together today. So 20, we'll begin with part A. This is 319, or sorry, 317. Page 317. Okay, we're going to read through part A together. We'll do the usual thing that we do, just one sentence at a time. There's one change that I want you to make, though. When we get to this part that says rebound ratio, whoever is reading this sentence, I want you to change this word to multiplier when you read it. Just read it out loud. Don't cross it out or anything right now. I'll remind you when we get there. Can I get somebody to start us off on this first sentence with Arnold Drop? Can I get a volunteer to read that? Just the first sentence. One sentence is all we need. One sentence and only one. Thank you. Go for it. Awesome. Can you pick someone to read our next one? You can just point to someone if you like. Awesome. Can you pick somebody to read our next one? It's a really short sentence. This is the one where I want you to change rebound ratio to multiplier. So when you get to this word, say multiplier instead. Rebound ratio, change that whole thing to multiplier. Perfect. Thank you. Can you pick someone to read the next one? You can just point at somebody if you're not sure of their name. Are you willing? Is that why you were turning around? Yep. Yeah. Awesome. Who's next? Please. This is a short one. Right in.
Write an equation that represents this data.
Do you want to just finish it up for us? 3 more words? Awesome. Thank you. All right. So we're going to try and write an equation for this. They gave us a table. What do you notice about the table? Yeah, it's missing stuff, right? It's not complete. Go ahead and copy that table down into your notes. We'll start there. We got number of bounces and height. Zero, 1, 2, 3, 4. 84.5, 67.6, 54.1. All right, I tried to give us a little bit of a hint. Also, we didn't do this activity. We skipped this section. But I asked you to talk about a multiplier. That's the word that we replaced the rebound with multiplier. So I'm trying to give you a hint that there is a multiplier that's going to get you from one of these values to the next. Could I get you guys to please find that multiplier for us the same way that you would have if you were finding a multiplier for a geometric sequence? So if you need to refer to your pink packets, I think I passed those back to you last class. Got a couple of those from other people. See if you can find me a multiplier. You are going to want a calculator for this. At least I needed one. What's our multiplier? What can we multiply 84.5 by to get 67.6? What can I multiply 67.6 by to get 54.1? Give that a shot. You've got some information in your pink packet about how to do this. See if you can remember how to find that multiplier. Grab a calculator if you need to. I'm walking around and I just heard somebody talking about whether it has to be bigger or smaller than 1. That's awesome if you're making that connection. Is this increasing or decreasing? It's decreasing. So is that multiplier gonna be bigger than 1 or smaller than 1? If it's decreasing, it's gonna be smaller than 1. Good for you. Great connection there. So we know it's got to be something smaller than 1. We actually had a little cheat code for how to figure out exactly what the calculator was by doing some, or what the multiplier was by using our calculator. Anybody remember that little cheat code? It had to do with dividing, didn't it? That's great. I'm glad you remember that. If you pick two numbers that are back to back, you can divide them. The question is, which one do you divide by which? Do you do the first divided by the second or the second divided by the first? First divided by second? Go ahead and try that. What is 84.5 divided by 67.6? What's that come out to be? 1.25, but that doesn't seem right, does it? We just said a second ago it had to be smaller than 1, didn't we? You got 0.8. Did you do the first divided by the second or the second divided by the first? You did the second divided. It must be second divided by first, right? When we reverse the order, we got the two answers we got were 1.25 and 0.8. Which one makes more sense? 0.8. Question? Tiny bit bigger, but it's pretty close though, right? If you rounded it, would it still be 0.8? Okay. Yeah, it's awfully close. Ooh. Mm-hmm. What percent less? I like it. I like it. So that's a great strategy where you're applying background knowledge that you already know. If we thought about these as free throw averages, then that's going to help us make a connection that'll help us remember things long run as well. Awesome. Okay, so we're doing about a multiplier of 0.8 each time. If you have that information, do you feel confident that you could work backwards and figure out what our missing parts of our table would be? Could you go ahead and do that? Our multiplier to move forward is 0.8. What are we going to do instead to move backwards, though? Instead of multiplying, we'll divide. We'll go the opposite. So try dividing by 0.8 a couple times. And let's round off our answers to 1 decimal place. Okay. If you need to take a walk and get some water, you're welcome to. I know that's really uncomfortable. All right, let me get my calculator. This is not something I'm comfortable doing in my head right now. 84.5 divided by 0.8 is, I'm just going to round that off to 105.6. And then we'll divide that by 0.8 again. We'll round that off to 132. All right, since this is our notes, and the whole point of notes is to help us remember later on something that we get totally right now, but we want our notes to be useful to us so that if we glance back at them, say at the end of the period after we've done 3 other problems, and if I glance back at this and I'm like, okay, I don't remember how I got 0.8, what could I write in here to help myself, future me, remember what did we do in the calculator to get 0.8? What did we do? We divided, and which did we divide? Was it this first one divided by the second or second divided by first? Second divided by first. So I don't know about how you guys, but me personally, I like to do little thought bubbles. Let me change my color here. This 0.8 here, how did I get that? I'm going to make a little thought bubble here that reminds me what I was thinking in my head to get it. What I did was I picked 2 and I did second divided by the first. I did 67.6 divided by 84.5 to get that 0.8. That's how I came up with that. And I like to put these in a little thought bubble. So if I'm looking at my notes later on, I can say, I ask myself the question, wait, where did that 0.8 come from? I've got like a record of how I got it. Some people, rather than do this, they would just write themselves a note, divide the second one by the first. Some people like to use arrows and that kind of thing. Make yourself a little note, something so that later on when you're working on your exit ticket, you have some record of how we got that 0.8. All right, before we move on, we want to do the major thing I'm going to ask you to do at the end of class. I'm going to ask you how to find A and how to find B. So if I give you a table, I need you to be able to identify from that table what is A and what is B. Does anybody want to take a guess what A is for this table? This guess would probably be based on what you already know about geometric sequences. You want to take a guess? It has a lot to do with the 0, but A is not 0. Do you want to take a second guess? If you're looking at that part of the table, you're looking in the right place. What do you think A is? Yeah, give me a number. 132 is absolutely A. That's awesome. Good for you. So you remembered from geometric sequences that A part of the equation came from the 0th term, or you knew to relate that back to 0. That's fantastic. So that 132 got us our A value. Anybody want to take a guess what B is going to be for this one? 105 is a great guess. Not quite. You're looking in the right part of the table. What do you think B is? 0.8? Yeah, 0.8. I don't know why I wrote 0.08. That's totally a typo right there. Nobody corrected me on that one. Oh, feel free. If you see me make a goof like that, let me know so I can fix it. That was probably me just trying to talk and write at the same time. Sometimes it doesn't go super well. So this 0.8 here that we got is going to be our B value. All right, let's move on to part B. We're going to try this a little bit differently this time. So if you're sharing a book with somebody next to you, make sure the book is sitting someplace where both people can see it. If you've got your own book, that's even better. I would like everybody to, we're on page 317. If your book's not open, go ahead and open it up to page 317. I'd like everybody to read through part B. Before we do, I want to give you one vocabulary word that you've probably not seen before. Has anybody ever seen this word before? Prospectus. Prospectus. So a prospectus is a report that a company gives usually once a year, sometimes once a quarter. And it just says how the company is doing. Usually it goes out to your shareholders, your stockholders. Sometimes the customers are interested in seeing a prospectus as well. But it's basically like a report card or a sort of a history for a company. Okay, so anyways, could you please read this silently to yourself? I'm going to give you about 15-20 seconds to do that. And then I'm going to ask you to cover it up with your hand and turn to your neighbor and give them a short synopsis of what's going on. Okay. Everybody in the room is going to do this. Okay. So rather than have you read it out loud to me, I want everybody to read it individually. And then I want you're going to turn, I'll tell you when it's time to do this. You'll turn to your neighbor. One person's going to give one little piece of what's happening. The other person will give a little piece. Where I don't want you reading though. I just want you remembering the important parts of it. Okay. So go ahead and read it. See if you can pick out the important parts of it silently to yourself. This is part B on page 317. Okay, what I want you to do is cover that up with your hand. Everybody cover it up. Once you're done reading, cover it up. I want you to turn to your table partner and just tell them in your own words one thing that's important in this little section, okay? If you're at a table by yourself, just either turn to somebody at a table next to you or turn to somebody behind you, okay? Go ahead. Go ahead. What's one fact from there that you're going to need to know to do the problem? All right, I heard some good stuff there. Let's go to our notes here. We should probably write some important stuff down. What's something important from this paragraph that we should probably write down? What do you think? X equals number of years since it was founded. That was really important. Thank you for that. What else should we write down? Y equals number of people. Okay, what's some other key information from this problem that we should probably write down? You see any numbers, any equations, anything like that? See the number 3? Oh, it's part of that equation, y equals, yeah, let's write that whole equation down. Y equals 3 times 4 to the x power. And then they asked us some questions. How many people founded the company? How can the growth of this company be described? So let's focus on this equation. There's 2 numbers in here, 3 and 4. And remember, our ultimate goal is to be able to look at an equation or a graph or a table and be able to figure out what is A and what is B. Can you identify, just looking at this equation, which one of those is A and which one is B? Is the 3 the A or the B? That's the A. And the B is 4. That's going to be the easy one on our little quiz, right? Remember, in a minute I said I was going to give you a quiz that was going to look like this. Do you think you're going to be able to tell me pretty easily what A and B are in this quiz? Yeah, I bet you will. Let's talk about what they mean, though. This looks a lot like, and I've heard several people say this today, make this connection today. This looks a lot like geometric sequence, doesn't it? What did A represent in the geometric sequence? The 0th term. A was the 0th term. In this case, we're going to say A is the starting value. So make your note that this is the starting value. And that's always going to be the value when x equals 0. And then when we were dealing with geometric sequences before, what did B represent? Does anybody remember? The thing that we multiply, I'm going to call it the multiplier. Oh, I'm so glad you remember that. If you remember that stuff, that's just going to make these exponential functions that much easier to deal with. So B is going to be our multiplier. So they asked us in this question, they asked us for 2 facts. They said, how many people founded the company? In other words, how many people were there at the beginning, at the start? When we were 0 years in, when x equals 0, the starting value was 3. So we can say that there were 3 people at the start. That answers the question of how many founding members were there. Founding members were people that were there at the beginning. They also asked us to describe the growth. Let me ask you this. Answer me this question. Is this a correct way to describe the growth? The number of people in the company goes up by 4 every year. Is that accurate? I'm seeing a couple of people shake their heads no. I'm seeing a couple of people shake their heads yes. The number of people in the company goes up by 4 each year. Yes? No. Okay, so we've got some emphatic yeses and some emphatic nos. If the answer is no, could you change that sentence to make it better? The number of people goes up by 4 every year. Ooh, where would you put the word multiplies in the sentence? Can you give me a new sentence? Okay, 2 options. The one that I said was the number of people goes up by 4 every year. The other one is the number of people multiplies by 4 every year. Which one's better? Multiplies, because this 4 is a multiplier, right? So let's write that down. Number of people multiplies by 4 every year. Okay, I got one last problem we're going to look at together. And I am super hopeful that I've got this all set up to go. Oh, I do. Wonderful. So for this, you're going to have to look up at the screen. We're going to sketch this picture. Hopefully, if I can find it. There we go. All right. Can you guys see that graph? No. The one on the screen? There are 2 important points here. I'll point them out to you. One of them's right here on the y-axis. It's the y-intercept. And then the other point that's really important is going to be this one up here. So I want you to make yourself a sketch of this. I'll show you what this is going to look like. I'm going to draw this on the whiteboard. When I transfer this over to my page, it's going to look like this. But go ahead and draw this in your own notes. Draw yourself a y-axis and an x-axis. Give yourself some tick marks on your x-axis. 2 in each direction should be fine. Give yourself some tick marks on your y-axis. Now your y-axis is going to need to go up to 6 at least. And make a sketch and make sure that your sketch is going through that y-intercept and it has that second point on it. It should look something like that. And then draw your curve curving up. I'm going to put this on my own notes while you're doing it as well. So this will be our final example. Then we're gonna go ahead and draw some stuff in our packet as well. Once we feel like we've got all this down. So keeping in mind our ultimate goal, I want to be able to figure out what is A and what is B by looking at this graph. All right, so our goal for today is, can we figure out what is A and B if we have a graph, or if we have a table, or if we have an equation? So far we've done equations and tables. This is our time for graphs. Does anybody want to take a guess on A or B for this graph? I'll tell you, they have a lot to do with these 2 points that I marked on here. We got a guess. What do you want to guess? Is A the y-intercept? What do you guys think? Does that make sense that A is the y-intercept? What we know so far is that A is the starting value, that A is the value when x is equal to 0. Is the intercept when x is equal to 0? It is, totally. Yeah, the x value would be 0 here. Is that how we did it when we were doing y equals mx plus b? The starting value b was the y-intercept? Totally. You got it. Nailed it. A is going to be 3 for this graph. And I'm going to make a note underneath it that it is the y-intercept. And I like having arrows, so I'm going to also draw a little arrow here. All right, B is the trickiest part. Getting B from a graph is the trickiest part for me of anything we're going to talk about today. So don't miss this part, all right? Anybody want to take a guess what B is? Or I give you some hints? We think it's 4. 4 is an excellent guess. 1's a great guess too. 2 is a good guess. All right, we got some great guesses. What do we know about B from our notes last Thursday? This graph is increasing or decreasing? Increasing. What's that mean about B? It's got to be bigger than 1, right? It has to be bigger than 1 because it's increasing. That's what we learned last Thursday. B's got to be bigger than 1 when it's increasing. So I heard 2, I heard 4, I heard 6 that are all bigger than 1. Anybody who don't want to double down on one of those? We also know that B is a multiplier. So let me give you a hint here. Right next to this point, go ahead and write me the coordinates of this point. The coordinates of this point are 0, 3. Do the same thing for that second point. I'm not going to give you the coordinates. I'll let you figure out what they are. It's 1 comma something, 1 comma 6. All right, there's a hint for you. Anybody want to make a new guess about what B is? What do you think? 2, because why? What is doubling? What are you seeing that's multiplying by 2 or doubling? 3 doubles to 6. Anybody else seeing that 3 double to 6? Anybody want to jump on the 2 bandwagon? Think B is 2? Who else thinks B is 2? Oh, you got a lot of followers there. You convinced a lot of people. It is 2. It is 2. If I look at this y value and I look at this y value, remember B is a multiplier. B is going to tell us how to go from this to this, which would be times 2. So B is going to be 2 because, well, because it's a multiplier. Yes. Where did I get that second point? So its x coordinate was 1.
How do you know that is the point?
Oh, that's a great question. How did I know that was the point was supposed to be used? We started off from a graph. So I'm just going back to the graph that I gave you ahead of time. And what I looked at when I saw this graph, this is an excellent question, guys. Don't miss this. When I saw this graph, because I've done this a million times, right? I knew that the important points I needed to look at were right here, that this point, right, this 3 was going to give me my A value. And I also knew that I wanted to make sure I figured out exactly where this point was. Because this has an x coordinate of 0, this has an x coordinate of 1. And I knew that I'd be able to use my y coordinates for these 2 points to figure out what B was. So I knew to have you mark those 2 points at the beginning because I had prior knowledge. So when I told you to mark those 2 points, I did that on purpose because I knew it was going to help you get there eventually. Now, you're going to have to figure out in the future the same thing, right? How are you going to remember to look for those 2 points on your graph? So I'll just show you this really quickly. Can you look up here for a second? Let me switch back to my dock camera here. This is the little exit ticket you're going to do in a second. Now for this, I actually marked these points on here for you. You see how I did that? So hopefully that's going to help you remember to look for those 2 points. Okay, but in the future, I might not mark those 2 points. You might have to remember to look for them. That's such a good question. Thank you for asking that. What other questions do you guys have before we move on? Okay, ultimate goal for today. Can you look at an equation and tell me which number is A and which number is B? You feeling pretty good about that? Give me a thumbs up if you're feeling pretty good about that. Can you look at a table and figure out what is A and what is B? This one's a little bit trickier. For A, we got to look for the Y value when X is 0. For B, we got to find our multiplier, and we find that multiplier by using division. And then lastly, let me move this out of the way. Lastly, can we look at a graph and find A and B? On the graph, we're looking for the y-intercept to give us A. And then B is kind of tricky. We need some coordinates of a couple points, and we need to look at the y coordinates of those points and figure out what's our multiplier between those. So let's get ourselves a good example into our notes here. And what do we want to do? Let's go ahead and go back to our packet, since this is where we put our most important notes. Can you guys give me some notes about A and B right here? What is A? Give me some words that I could use to describe A. Yeah. Say again. 0th term. Now, if it was a sequence, it would be the 0th term. This is no longer a sequence. So how could we change that instead? What do we use in our notes just a second ago to describe it? The y-intercept. So A is the y-intercept. And we also talked about A in terms of like a situation. Look at part B of number 20 that we just did a second ago. It was the starting value. And what do we look for on a table to find A? The 0th term. It had something to do with when X was 0. I'm going to write the Y when X equals 0. It's the Y when X equals 0. Give me some words to describe B. Multiplier. That's kind of the key one for B. And I'm going to make myself a little note here about my cheat code for finding B. If I have 2 Y values that are back to back, we use division to find it, right? We do the second one divided by the first. So I'm going to write divide second by first Y value. I don't know if that's the best way to put that into words, but that would work for me. Again, remember, these are your notes, so you don't have to copy exactly what I'm writing down here. Copy what's going to work for you. Then I want us to make a good concrete example where we show all of this. So let's do an equation and a table and a graph and see if we can make some connections between them. So I want to do something kind of simple. So why don't we do the equation? I'm just going to make something up here. Y equals 2 times 3 to the x. A equals and B equals. What's A for this equation that I just invented? A is 2. What's B? B is 3. Let's make ourselves a table to match this. I'm color coding these. I'm going to do all my A stuff in red and all my B stuff in green here. So can someone tell me where I'm going to find the 2 on my table? It's going to be the 0 when X is 0, right? So 2 is going to go here. And I'm going to, again, I like lots of arrows. Some people don't like arrows because it makes their paper kind of messy, but I'm going to draw an arrow there. And can someone tell me where I'm going to find my 3 on my table? Yes, beautiful. So it's my multiplier. It's going to help me figure out the next Y value is going to be times 3. And that's going to give me my next one, which is 6. Awesome. Awesome. I like it. And then 6 times 3 is 18. Anybody know what 18 times 3 is? Help me out. What do we got, Isaac? 54. Beautiful. And I'll go ahead and draw another arrow times 3 here. And I'm also going to try and illustrate my little cheat code. Oh, let me draw my arrow. I'm going to illustrate my little cheat code here. Remember how we found what the multiplier was from the table? We picked 2 numbers that were back to back, and we did the second one, 54, divided by the first one, and that got us our multiplier also. Can someone check that in their calculator? Make sure I'm not lying to you. 58 divided by 18. Is that indeed 3? Does it work? Okay, cool. So that's another way that we can find our multiplier. And then we should probably make ourselves a graph here too. So I'm going to make myself a graph. And I'm going to make sure we have enough space to get our y-intercept and that first point on it. So I need to go up 6 again. 1, 2, 3, 4, 5, 6. 2. Where does that A come from on our graph? Where are we going to see that value of 2 on our graph? It's at the y-intercept, right? So go ahead and draw a point there at 2 on your graph. That's going to be our y-intercept. Our y-intercept has the coordinate 0, 2. And then we're going to have another point that we're going to draw. What am I going to multiply this 2 by to get my other point? Our multiplier is 3 times 3. And that's going to get me 2 times 3 is 6. So we'll have another point at 1, 1, 2, 3, 4, 5, 6. So our graph would look like that. And again, this 3 is related to that. All right, so I got arrows all over the place, but I feel like I would be able to follow that. Okay, you guys ready for this? Yes, yes, you are. Yes, that's the attitude. All right, I'm going to pass this out. I would love for you to, this time on our little quiz thing. This is, again, remember, this is not for points, so no need to get anxious about this. Deep breaths, do the best you can. I just want to see where we're at. For this one, I would love for you to try this without your notes. I'd like you to do a first draft without your notes, okay? So I want you to treat it like an actual quiz. Close up your packet, close up your notes, and try it. Once you've got it done or you've gotten as far as you can, then I want you to open up your notes to check it or to get yourself a hint, okay? When it's done, you're going to drop it in the tray over here. I'll just have a quick look at it and I'll circulate around and see if I need to chat with anybody about any mistakes. Remember, it is okay to make mistakes. I don't want you to worry about your grade on this because it's not going in the grade book. Please do your own work. I'm not interested what your neighbor knows. All right, try it without your notes first, and then you use your notes to check it or to get a hint if you need to. And then when you're finished, you can drop it in the tray up at the front. I'll go ahead and put the assignment up on the board here in just a moment. You know who's out? Hey, now let's keep our hands to ourselves. All right, with the remainder of our time, please, let's get a good start on our assignment here. Let me know if you have any questions. I'll be around to. Oops, that's not right, is it? Thank you for correcting my mistake. That would be kind of mean to make you turn it in today already. How about the 26th? I'll give you a couple days for that. Thank you for my correction.